Hi, welcome back to NPA Teaching. In the last video, we discussed the concept of linear programming and the formulation of linear programming problem. Now see how to find solution to a linear programming problem. We can solve linear programming problem either by using graphical method or by using simplex method. The graphical method for solving linear programming problem tries to find out the maximum or lower point of the intersection on a graph between the objective function line and the feasible region. This method can be used when there are only two decision variables. The two axes of the graph, that is x and y axis, represents two decision variables, for example x and y. Now we are going to solve a linear programming problem with two decision variables by using suitable examples. There are various steps involved for solving linear programming problem by using the graphical method. The first step is that formulate the linear programming problem and develop objective function along with all the constraint functions. We have already discussed and understood in the last video that the mathematical formulation of the linear programming problem. Anyway, we are again going to repeat here by using the another example. A company manufactures two products, namely X and Y. And these both products are processed on two machines, that is machine 1 and machine 2. The manufacturing of product X requires the processing of machine 1 by 6 hours per unit. At the same time, the manufacturing of product Y requires the processing of 6 hours per unit of machine 1. Similarly, the manufacturing of product X requires the processing of 2 hours per unit of machine 2, and the manufacturing of product Y requires 4 hours per unit of machine 2. The total availability of machine 1 is 7200 hours per month, and the total availability of machine 2 is only 4000 per month. So this is the constraint in the given model. See, the profit per unit sale of the product X is rupees 100 and the product Y is rupees 80. Now our question is that find out the monthly production of X and Y to maximize the profit by using the graphical method. See, from our example, manufacturer wants to produce two goods, product X and Y, which are considered as our decision variables. So we have only two variables. We can use graphical method for solving linear programming problem. Now we are defining objective function. See, the company wants to maximize the total profit. The total profit is represented by capital Z. The company makes a profit of rupee 100 per unit when product X is sold and rupee 80 per unit while product Y is sold in the market. So these 100 and 80 are the coefficients of objective function. So here the profit maximization is the objective function. Maximize profit Z is equal to 100x plus 80y. The next one is restrictions or limitations on the decision variable, which is generally considered as a constraints. In our example, the constraints are the available time of machine 1 and machine 2. But see here, the availability of hours under machine 1 and machine 2 are very limited. As per our example, see, each unit of product X requires 6 hours of machine 1 and Y requires 4 hours of machine 1. So the total availability of time under machine 1 is only 7,200 hours per month. So this can be represented mathematically as 6x plus 4y less than or equal to 7,200. So 7,200 is our maximum available time under machine 1. Similarly, for producing each unit of X and Y requires 2 hours and 4 hours of machine 2 respectively. So the total available time under machine 2 is only 4000. So we can represent this as mathematically 2x plus 4y less than equal to 4000. Less than equal to we are using here because the maximum available time under machine 2 is 4000. The next one is non-negative constraint. That means the value of x should be greater than equal to 0, and similarly the value of y also greater than or equal to 0. So here the first step is completed, that means formulating linear programming problem. So here the problem is maximization of profit, that is z is equal to 100x plus 80y. Subjected to the constraints, we have two constraints, that is 6x plus 4y less than equal to 7200 and 2x plus 4y less than equal to 4000. And at the same time the value of x should be greater than equal to 0 and the value of y also greater than equal to 0. Once the mathematical model is framed, then the next step is construct a graph and plot the constraint lines. See, here we have a graph. On the horizontal axis we are taken the commodity or product X, and along the y axis we are taken the commodity Y. For plotting the constraint lines on the graph, first we want to find out the coordinates of the constraints. For this purpose, replace the inequality sign in each constraint by an equality sign. First we have to consider the constraint 1. Constraint 1 is 6x plus 4y less than equal to 7200. First step is we are removing the inequality sign and making it as equality sign. So as 6x plus 4y, instead of less than equal to, we are using the equal to 7200. Now putting value or finding out the value of x by considering the value of y is equal to 0. See, our constraint now is 6x plus 4y, which is equal to 7200. Now we are assuming the value of y is equal to 0. Then the equation will become 6x plus 4 into 0. Instead of y we are using 0 is equal to 7200. So which is equal to 6x is equal to 7200. If you are solving for x, then it is 7200 divided by 6, which is equal to 1200. Similarly, in order to find out the value of y, let us assume x is equal to 0. Then substitute the value of x is equal to 0 on the equation or constraint, that is 6x plus 4y is equal to 7200. So here putting x is equal to 0, then 6 into 0 plus 4y is equal to 7200, which is 4y is equal to 7200. So value of y is equal to 7200 divided by 4, which is 1800. So we have 2 points which make constraint line are 1200, 0 and 0 and 1800. To mark the points on the graph, we need to select appropriate scale. Which scale to take will be entirely depending upon the maximum value of x and y, which we are already going to calculate or calculated from the coordinates. See, here we are going to take 0, 500, 1000, 1500 and 2000 in both x and y axis. Now we are drawing the line joining 2 points, that is we are calculated from the first constraint, that is 1200, 0 and 0, 1800 to represent the first constraints. So every point on the line satisfy the equation or equality, that is 6x plus 4y is equal to 7200, and every point below the line will satisfy the inequality sign, that is 6x plus 4y is less than equal to less than 7200. In the similar way, consider the constraint second, that is 2x plus 4y less than equal to 4000. Now first we have to convert the inequality into equality. So the equation will become 2x plus 4y is equal to 4000. Now find out the value of x by assuming the value of y is equal to 0. So 2x plus 4y is equal to 4000 will become 2x plus 4 into y is equal to 0. So here 4 into 0 which is equal to 4000. So the equation will become 2x is equal to 4000. The value of x is equal to 4000 divided by 2 which is equal to 2000. So one coordinate is 2000, 0. Then find out the value of y by assuming the value of x is equal to 0. So here the equation will become 2x plus 4y is equal to 4000. So instead of x we are substituting x is equal to 0. So 2 into 0 plus 4y which is equal to 4000. So 4y is equal to 4000. The value of y is equal to 4000 divided by 4 which is 1000. So we got the coordinates, that is 2000 and 1000. Now we are drawing the another line joining the 2 points, that is x is equal to 2000 and y is equal to 1000, to represent the second constraint. So this is the line. Every point on the line satisfy the equality on the equation, and every point below the line will satisfy the inequality sign. So the blue line which represent 2x plus 4y is equal to 4000. So we drawn the graphical representation of two constraints. After drawing two lines which represents two constraints, the next step is to identify the feasible region. The feasible region is the region which is bounded by the constraint lines. All the points inside the feasible region or on the boundary of the feasible region or at the corner of the feasible region satisfy all the constraints. See here, both constraints are less than or equal to type, which is mainly happening in the case of maximization of objective function. Hence, feasible region in this case should be inside of both constraint lines. So here the final shaded area is called feasible region, or it is solution space of the given linear programming problem. Any point inside this region or shaded region is called feasible solution, and this gives the value of x and y that satisfy all the constraints. Hence the feasible region here is the polygon OABC, where O is origin whose coordinates are 0 and 0. Then O, A, B and C are called, generally it is vertex or corner points of the feasible region. The graphical solution can also be used to find the optimal solution of a given problem. So here finding the optimum point is the first final stage. Any point in the feasible region that gives the maximum or minimum value of the objective function, which is called optimal solution. In the feasible region, we can see there are infinitely many points that satisfy given constraints simultaneously. But see how to find or how to get the maximum or minimum value of the objective function. See in this here how to find the maximum value from the given objective function, that is x is equal to 100x plus 80y. See, the optimal solution always lies at one of the vertices or corner of the feasible region. See here we have 4 vertices or corner points, that is O, A, B and C. In the corner point O, which is the origin where the value of x and y are 0 because it is an origin point. The second corner point is A, where value of x is equal to 0 and the value of y is equal to 1000 from graph, which we can easily perceive from the graph. The third corner point is B, which is the intersection point of two lines on the graph. In order to find out the value of x and y on the point B, we have to solve both equations simultaneously. We will do it. And consider the last corner point, that is C, where the value of x is equal to 1200 and the value of y is equal to 0. So in order to find out the value of x and y at point or corner point B, we have to solve the simultaneous equation. So here the simultaneous equation, see at point B, the intersection of two constraint lines, that is 2x plus 4y is equal to 4000 and 6x plus 4y is equal to 7200. So if you solve these two equations, because we have two equations with the two unknown, that is two unknowns are x and y. So the 2x plus 4y is equal to 4000, which is the equation 1. 6x plus 4y is equal to 7200, which is equation 2. Here the value of y in the both equations are same, that is 4y. So we are just subtracting it here, both equation. So if you are subtracting equation 2 from 1, then we will get 2x minus 6x, which is equal to minus 4x, 4y minus 4y, which is equal to 0, then 4000 minus 7200, which is equal to minus 3200. So from this equation we can calculate the value of x, which is equal to 3200 divided by 4, which is 800. So we have got the value of x is equal to 800. Now substituting the value of x is equal to 800 on any one of the equation. For example, here we are substituting on equation 1. Then 2x plus 4y is equal to 4000. This is the equation 1. Substituting value of x is equal to 800. Then 2x, which is 2 into, instead of x we are substituting 800. So 2 into 800 plus 4y, which is equal to 4000. So 2 into 800, which is 1600, plus 4y is equal to 4000. By isolating 4y, which is 4000 minus 1600, where 4y is equal to 2400, y is equal to 2400 divided by 4, which is 600. So by solving both equations simultaneously, we got the unknown values of x and y, that is x is equal to 800 and y is equal to 600. So at corner point B, the value of x is equal to 800 and the value of y is equal to 600. In order to find out the optimum point, that is maximum profit from given four corners O, A, B and C, substitute the value of x and y in each corner points on the objective function. In our example, the objective function is to maximize profit, that is maximize z is equal to 100x plus 80y. From the first corner point, that is O, the value of x is equal to 0 and the value of y is equal to 0. Substitute value of x and y is equal to 0 on the objective function, then z is equal to 100 into 0 plus 80 into 0, which is given the solution of, which will give the solution of 0. Consider the second corner point where the value of x is equal to 0 and the value of y is equal to 1000. Substituting these values on the objective function, that is z is equal to 100 into 0 plus 80 into value of y is equal to 1000. So which will give the value of 80,000. And consider the third corner point, that is B, where the value of x is equal to 800 and the value of y is equal to 600. Substitute all these values are on the objective function, that is z is equal to 100 into 800 plus 80 into 600, which will give 1,28,000. And the last corner point, that is C, where the value of x is equal to 1200 and the value of y is equal to 0. Substitute these values on the objective function, then it will become z is equal to 100 into 1200 plus 80 into value of y is equal to 0, which will give the value of 1,20,000. Out of these calculated values on the objective function, the highest value or profit is 1,28,000. This is considered as an optimal or maximum profit. In order to get the maximum profit, company wants to produce 800 units of the product X and 600 units of the product Y per month. So this is the solution to the given linear programming problem. See, the graphical method is one of the easiest way to solve a small linear programming problem. But this is useful only when the decision variables are not more than 2. What happens if we have more than 2 variables? In this case, it is not possible to plot the solutions on two-dimensional graph. If we have more than 2 variables, we can use another useful method of solving linear programming problem. which is known as simplex method. We will discuss this simplex method in the next video. Have a nice day and see you in the next video. Thank you.